Okay, so what we're going to be doing is looking at the information, filling in the graph, and creating a function on the graph based on what they tell us. Okay, so we know that we've got distance that was run, and we have the time that it was run. Okay, because we know that Mark is training for a 5K running race. So we have a summary of his 40-minute practice run on Sunday. So the first clue says, in the first 8 minutes, Mark ran 1 kilometer. So before I can start graphing this, I need to fill in my increments. So somebody tell me, what are my increments going to be for time?
4, 8, 12,
Yep.
16, or 18, whatever.
Yep, I'm going to skip count by 4s. Because I don't like this to be super cluttery, I'm going to say, okay, that's 8, this is 12, that's 16, this is 20, 24, 28, 30, 32, right? Excuse me, 32, 36. I just don't, it's the exact same thing. They're all even. It gets really cramped down there. You can put all the numbers. I mean, there's nothing wrong with that. But I just want you guys to know what I'm doing. But then going vertically, it's really easy. I'm going by half kilometers.
I didn't skip.
It's okay. You don't have to. We're still going to have the exact same graphs. Right? So we're keeping track of how far Mark is going to run. So in the first 8 minutes, he ran 1 kilometer. So if I go over to 8 and 1, that's going to be his first part of the function of his travel. Somebody's phone is blowing up.
That's not me.
Okay. He increased his pace and completed 3 kilometers over the next 16 minutes. So how many kilometers has he gone now?
17. What?
He went 1, and he's just completing 3 kilometers, 3 more. So he'll be at 4. And how many minutes? What will he be at? What's 8 plus 16?
24.
24. So this is where my next point's going to be, because this is the 3 kilometers over the next 16 minutes. Right.
Is it not supposed to be straight?
I mean, as best you can. I know mine doesn't look. I'm not going to use a ruler because I don't think you guys do. So just do the best you can.
Oh, mine is not straight.
That's
Mine goes like this.
This morning for breakfast, I had Chick-fil-A. It was magical. Yep.
You made that for breakfast?
Oh yeah, the chicken biscuits. So
I
good.
get the chicken biscuits. Or no, I get the
The
mini,
little chicken minis.
the
Yep.
mini things, chicken minis.
So
And
pretty
then I
good.
take the bread off and then I just eat the chicken nuggets.
You don't ever eat the biscuit part?
Not really.
That's the best part.
I know, but
I
it's
don't
super
like
filling.
biscuits.
Yeah.
Every time.
Okay. So Mark took a 10-minute break. So I'm at 24. So I need to go all the way to 34 to show 10 minutes. And then he finished his distance of the 5 kilometers during the last 8 minutes. This should really say 6 minutes. During the last 6 minutes. Right? So this was Mark's run for the day. Right? We can see how far he went. We know he went 5 kilometers because that's what it told us. We know it took him 40 minutes. Right? How are we feeling about this? Good? Okay, let's go on to the next page.
Are we doing the practice page today?
Nope. We're just going to work on this packet together. Okay.
Are you making a video right now?
I am. Mm-hmm.
Oh my gosh.
Well, it's fine.
I did not know you were making
It's okay.
Should I start shouting?
All right. Sarah is walking her dog after school. Below is a summary of her 20-minute walk. All right. So we have to go down here and we have to fill in our increments first. So this time it's going by 2 minutes. So I've got some of my numbers in there so it's not too cramped. But it's still all equal increments. And then how about my y-axis? What are these increments? So this is going to be 0.2. Okay, so let's go ahead and look at the description. It says, in the first 4 minutes, they walked 0.2 miles. So I'm going to go to 0.2, where 4 minutes would be. Right, got my little section of the function. They picked up the pace and completed 0.5 miles over the next 6 minutes. So 4 plus 6 is going to be at 10. And then I'm adding 0.5 miles, so I'm going to be at 0.7. All right.
Wait, what's the time?
So we're at 10 minutes because 4 minutes plus 6 minutes gives me the 10. And then I'm at 0.7 because I added 0.5 to 0.2. She saw a friend and wanted to pet her dog, so she stopped for 4 minutes to chat.
4 minutes.
So I'm going to go from 10 to 14.
Straight across,
And
right?
yep, she's not moving, right? But time is passing. So
Yeah, straight across, meaning like horizontal line.
Sarah realized she had to get home to go to swim practice, so they raced home the last 6 minutes. So notice that this graph is showing her distance from home. So we have to go all the way back down here to show her racing home. Okay, so this is what your graph would look like because she's away from her home and then she goes back to her home.
I know what people at home right now have this paper.
Nope, I'm just going to put a file on Canvas and hope for the best for them.
Oh, okay.
They can open it on Notability, right?
Oh. Wait, but if you're making a video already, are they doing it today?
Well, there are people that are home today, so then they would check Canvas and see this.
Oh.
Yep.
Wait, how would they see it if you haven't posted it already?
Well, they're going to see it later. Yeah.
But-
Okay, how far did she actually walk with her dog? Who can tell me the actual distance she walked?
7.7 miles.
Well, that was one way.
Oh.
And
Oh,
so
14.
1.4 miles.
1.14.
All right, she walked
Oh. Yeah.
1.4 miles with her dog. Right, because it's 0.7, hangs out with her friend, and then races back 0.7 miles.
The only thing I don't like about my glasses is how they fall up.
Yeah,
Yeah, it's the worst.
that's tough.
And literally, there's nothing you can do.
Yeah.
Everyone I know who has glasses complains that like their mask breathing all over their
Mhm. Yep.
Especially in choir.
Okay, do you guys want to try Thomas and Jerry training for their mountain biking race by yourselves?
No.
You know,
You want free answers.
You need
Okay, all right, we'll go through it together, but you guys are going to have a quiz where you're going to have to do this by yourselves, okay?
I'll do it by
When's that
myself.
day?
Just
Okay.
wait a couple minutes.
I'll do the quiz.
Okay, so let's go ahead and fill in the increments, right? We have elevation and we have time, and they're going on the mountain biking, right, practice. So I'm going by 5-minute increments. This is a 50-minute bike ride. And then the elevation goes by 50 feet increments.
Oh, I just did it, or like I skipped a couple.
Okay,
Like I just did the whole 100.
that's fine. Okay, so it says in the first 15 minutes they climbed from 0 to 100 feet. So we'll be right here.
So to 100.
During the next 15 minutes, they increased their elevation to 400. So they didn't add 400, now they're just at 400. So I'm actually going to be,
30.
Yep,
They're at 400.
because it just increased to 400, it wasn't 400 more. They came to a lookout and took 10 minutes to enjoy the view, right? So I'm going to go over 10 minutes to 40. They're not increasing their elevation, they're just staying put. They raced back to their cars to finish the 50-minute ride. So then we can finish down this way, kind of like going back from home. And they just raced down, which you can go faster, right? When you're going down a hill as opposed to up a hill.
I was gonna say this graph looks like looks a lot like the other graph that we just did.
Yep. Okay, so here's a question. Do we know the distance they traveled? We know their elevation, but do we know how far they actually rode their bikes?
It says elevation in feet.
Right, we know how high they are above sea level, but we don't know how far they actually rode their bikes between one point and the other.
If you look up how far in meters is 800 feet above sea level.
But you don't know, like, are they, like, is it sometimes, is it constant, like, we don't know what the paths are, the trails. So do we know the distance they traveled? No, we don't have that information.
Don't have that info.
Right, that would be a different graph.
I drew a man jumping on a trampoline.
Okay.
Oh, I forgot to draw the face.
Okay, we have two more graphs. These are going to be slightly different than what we've been doing. This one, I give you the information, and we're going to be looking for intervals. Who can tell me what an interval is?
The maximum number to one value.
Not quite.
In
What's it?
between.
It's in between, right, Vale, Tiffany? An interval is talking about a window of time, okay? Like, if you're doing, let's say you're a swimmer and you're practicing and you have like 3 minutes to do a certain distance and then you have to start again after that 3 minutes. So you have interval timing, or maybe your coach makes you run a certain amount of time over and over, like run for 3 minutes, wait for 2. Run for 3 minutes, those would be intervals, okay? So we're going to be looking and evaluating cars in a Starbucks drive-thru throughout the day. So how many cars were in the drive-thru? And we're just going to look at the graph and look at the question and figure out what fits best. Okay, pretty straightforward stuff. So part A says, circle a time interval below where the rate of change is constant. So how do I know I have a constant rate of change?
When it's going up at the same every time.
So what does that look like?
It should be straight.
It should be straight, right? Okay, and does it have to have an increase or a decrease, or can it be a flat line?
Increase.
It has to change, right? Increase or decrease, it has a change. Okay, so that will help with this. So which of these intervals, 6 to 7, 9 to 1, or 2 to 4, do we have a constant rate of change?
It's 9 to 1. 2 to 4?
Well,
It's 9 to 1.
is anything changing here?
Ah.
No, that's just a constant. That's not a constant rate of change. Yeah, let's go ahead and label our graphs. We have 8 a.m., 9 a.m., 10 a.m.,
No.
11 a.m., noon.
7 a.m.
I just started labeling 14 and then I realized that's not how I'm talking.
And then we're going by increments of 5s. Right? So where do we see a constant rate of change? We need to see change here. Not just a constant, but a rate of change. Which of these 3 choices shows a constant rate of change.
6 a.m. to 7 a.m.
6 a.m. to 7 a.m. 9 to 1 is just a constant, but no change.
But it's changing 2 p.m. and 4 p.m.
But do you see how that's not a straight line?
Oh, it has to be a straight line? Okay.
Yep. So change is constant, and we're looking for a straight line. Right? Lots to think about here. Michaela, do you need me to hold on to your phone for you? You sure? Okay, then can you put it where I can see it on the other side of your pencil bag? Thanks. All right, part B. Circle a time interval below where the function is non-linear. So where do you see in this situation something that's considered non-linear?
Oh, I know.
Nick?
B 1 p.m. to 4 p.m.
Yep, and how did you know that?
Because it curves. It's not a line.
It curves, right? I should probably put an E in that word. Curves.
Oh, I read it just like that. I remember what
Mhm. Yep. It either has to like go increase, decrease, increase, decrease, that makes it nonlinear, or a curve, right? Circle the time interval below where the function is decreasing.
C.
C.
The only one of these where it's decreasing is between 2 and 3 p.m. Right? Okay. Now, what ordered pair could represent the maximum value? So,
9 a.m. to 1 p.m.
well, that's not really an ordered pair. So there's lots of different answers here, right? So you could have a bunch of different ordered pairs to represent the same maximum value. So one of the ordered pairs would be 9, 20, right? What does that 20 stand for?
The
Number of cars in the drive-thru at
9 a.m.
9 a.m. Or you could have 10, 20, 11, 20, 12, 20, or 1, 20. All of those would be correct answers. You only have to put one. I'm just showing you all the possibilities. What does that mean?
What do you mean? What does that mean?
It has the most cars throughout the
Yeah, so at 9 a.m., there were 20 cars in the drive-thru, which was the maximum. Right, that was the most cars that they had in the drive-thru at one time. You gotta really want your Starbucks to wait in that drive-thru.
Or, oh my goodness, I was gonna get Chick-fil-A
Sounds
the
like
other
the
day.
Starbucks is there 32 and 38.
I was gonna get Chick-fil-A the other day, the one in Carmen.
It goes really fast.
Yeah, I know, but
It's intimidating, but it
The
does go
line-
really fast.
the line was like all the way out to the intersection.
Oh, I believe it. 100%.
But that's if it's like that, I just do the curbside.
Yeah.
There's literally a
They're so
Chick-fil-A
fast.
in Westfield where it was like backed all the way up where you could barely get into any other store.
Yeah.
Chick-fil-A's so fast.
You know,
Okay.
That's the Chick-fil-A.
So what could my minimum ordered pair be? I have a couple answers that could fit this requirement.
Ooh, I know.
Oh, 6
6, 5.
6, 5, 4,
and 4, 5.
4, 5. And what do those represent?
The lowest, the minimum.
Mm-hmm.
No. It can't be. There, 4 p.m.
That's the minimum.
No, 4
4 p.m.
is lower than the 5.
At
What?
6 a.m., there were 5 cars in the drive-thru.
And at 4 p.m. there was 5.
Which was the minimum. Right? Or you could say at 4 p.m. there were 5 cars in the drive-thru, which was the minimum. Okay.
Wait.
Okay. You guys want to try the next one? We're almost done. Yay!
Yay!
Okay. This next one, very relevant, shows the number of people waiting in line to get a COVID test throughout the day. right? I don't know about you guys. I've actually waited in line. I've been in a really fast line. I've been in a really slow line. One time I had to do in a drive-through in the summer. That's what they did. It was terrible.
I haven't even been.
It's very lucky. Very lucky.
You say that.
Knock on wood. Knock on your desk. All right. Don't jinx yourself. Okay. So we have different times. Let's fill in the times. They're, of course, going by hours. So let's fill these in.
I haven't had to get a COVID test and I'm happy about that. It's not that hard.
I tried to do that.
Oh, it's like the flu test, but worse, and I don't like the flu.
I mean, it's not glamorous, but it's
Yeah,
it's necessary, right?
The flu
It's
test?
not as hard as they I would rather get a shot.
Nah.
Like, I like shots.
That might just be you.
It's definitely just you.
You'll be ready for the vaccine, right?
Yeah.
Okay, circle a time interval below where the rate of change is constant. So remember, we're looking for a straight line that's actually changing. There are several opportunities here with this graph. So which of these fits that?
9 a.m.
Description.
to 10 a.m., 12 to
Yeah.
12 to 12, or 10 to 12.
10 a.m. to 12 a.m. 12 a.m. Yep. Okay.
Oh,
And then 4 to 5, of course, it was decreasing. Right? How about where the function is nonlinear?
Oh,
9 to, or no,
4 p.m. to 6 p.m. What
no,
p.m. to 4
3, yeah, 4
Ah,
to 6. Or
1 4.
it would be 1 to
Okay.
4.
So if I look at 9 to 1, what's happening here? Is that linear?
Yeah.
Yes.
Is it a constant rate of change, or does it increase, decrease? Yeah, so that's nonlinear right there. Remember we had that zigzaggy on our notes last week that was confusing? So this is going to be nonlinear. 9 to 10 is a straight linear, and 1 to 4 is straight and linear. Or no, 1 to 4 is not, but 2 to 4 is.
Wouldn't 4 p.m. to 6 p.m. be non-linear since it's not a line?
It is.
It would, but it's just not one of the choices. You could put 1 to 4 because if you look, it's going, you know, negative and then increasing. So this could work too.
Oh, this one's 3 to 5.
Where is it decreasing?
2 to 4.
It's 2.
No, it's not. It's 12 to 2.
12 to 2 is decreasing. Right? 2 to 4 is increasing, and 6 to 7 is increasing. All right, what's my maximum value here? There's only one.
12:45.
12:45.
Or just 12.
And what does it represent?
Yeah, 12,
The highest. No,
the maximum.
At noon, there were 45 people in line. Which was the most. Right. Maximum, most of the day.
I just said the most they have.
What about my minimum?
9.
9, 10. And what does that represent?
The lowest amount.
Yeah, at 9 a.m. there were 10 people in line.
10.
Which was the least?
9, 8.
Right? So we sketched some functions, we analyzed some functions. How are we feeling?
You're good.
Good. All right. Thank you guys.